Assalamualaikum. My name is Nur Shazza Shazwana binti Zulkifli from RK20. We're going to present our modern control system on automatic vehicle system. So, for our introduction, firstly, I'm going to talk about what are control system. Control system is the study and design of automatic system. A field known as control engineering has become important in modern technical society. From device as simple as a toaster or a toilet to complex machine like space shuttle and power steering. Control engineering can be said is a part of our everyday life. So, according to Wikibook, formal definition for control system is a device or a collection of devices that manage the behavior of other device. Some devices are not controllable. So, a control system acts as interconnection of components connected or related in such a manner as to command, direct or regulate itself or another system. So it can be said that control system is a conceptual framework for designing system with capability of regulation and tracking to give a desired performance. For our aim is to build an automatic vehicle driving system. Next, our objective. Our objective is to draw the board plot system and determine the gain and phase of the system that we will design. So the next objective is to design a compensator, whether it's lead or lag, so that the phase margin will be at least 50 degrees.
Assalamualaikum and good morning. My name is Nura Manina binti Muhammad Marzuki from RK20. This automatic vehicle control has its advantage. The first advantage is it will prevent from the accident due to the automatic collision control. Second, the cost is very effective. And the third is the traffic flow will smooth due to the lane driving. Our mini project problem is automatic vehicle control. So we will show step by step to solve this problem. First question is draw the board plot of the system and determine the gain and phase margin of the system. Assume k equal to 1. Second question is you are required to design a compensator, lead or lag, so that the phase margin will be at least 50 degrees. Produce your design.
Hi, Assalamualaikum. My name is Nur Aliani Adila and I'm going to discuss the calculation of our mini project. The project is about an automatic vehicle control that consists of open loop system and also the unity feedback system. So for our group, we are only going to focus on open loop system that we combine the driver system and vehicle system together by using the multiplication. By using the value of k that question gave, we are able to find the value of transfer function, which is gs. Next, from time domain, we change it into frequency domain by substitute j omega into term of s in previous transfer function equation. By doing the simple calculation, we are able to analyze the number of zeros and poles, where zeros are from numerator and poles are from denominator. Actually, these calculations are being used to plot the board plot, but for our project, we are going to use Scilab to execute the graph by using our previous transfer function equation, which is in time domain. From the Scilab, we get the value of phase margin, which is 9.68 degree, and gain crossover frequency, which is 0.066 Hz. But then we have to change it into radian per second by multiplying 2 pi with the value that we get 0.451 radian per second. As we know, 1 Hz equal to 2 pi radian per second. Since our 0 is smaller than poles, we are going to design phase lead network with Vmax is equal to 55.32 degree, which we get from the subtraction of PM required with PM current, which PM required is 50 degree, which given from equation, and PM current is from Scilab. And then we plus it with 15 degree, which is safety margin. Using the value of Vmax, we've done a simple calculation to get a value of alpha, which is 14.854. Next, we substitute the value of alpha into omega formula and set to 0.415, which we get from gain crossover frequency, so that we able to obtain the value of tau, which is 0.625. So from the value of alpha and tau that we obtained before, we are able to rewrite the phase lead network transfer function, where this new equation will apply it into Scilab to confirm our phase margin are satisfied the requirement of this mini project.
Assalamualaikum. Hi everyone, my name is Siti Aisyah binti Abdul Rahman. I am from RK20. Okay, I will present about the coding for the problem number 3. Okay, for the first line, we will write S equal to %S and enter. Okay, then the second line, for the second line, we will write as numerator equal to 1 time bracket S plus 2 bracket semicolon and then enter. Denominator equal to S square time bracket S plus 12 bracket semicolon, enter. Third line, fourth line, TF equal to SYS lead bracket comma C comma numerator comma denominator and bracket semicolon. After that, after you write all the equation, then you have to write show margin for the graph. Show underscore margins bracket df bracket and then enter. You have to wait until the graphic window show you the graph for the magnitude and phase. Okay, for the magnitude, we have margin at this, and for the phase, we don't have the margin. Okay, then after that, write bracket PM GCF bracket equal P underscore margin DF and enter. Okay, this the value for the margin. Okay, then write PM PCF bracket equal G underscore margin df. Okay, for this equation we don't have the value, so that after we see the previous graph, so you cannot see the value that that's why this part don't have value. Okay, that's all from me, and this all the equation for the problem number 3. Okay, thank you.